Right, the last question. We made it. So, question 19, the bouncing ball question. Right. Yeah, so lots of bouncing balls in this paper three. Anyway, okay, this is a freeze frame photography question. Yeah, Alex, I love these. All right, where you have to analyze a photograph that contains many frames per second. Right, so it's given us here 20 images per second of a bouncing ball. Now then, show the distance it fell between X and Y is about 0.4 meters. Okay, so how long does it take to fall from X to Y? Okay, well, so how long is it going to take first? So how many frames are we forward? Right, so here's our start point. We've got one, two, three, four, five, six. So we've got 6 frames after the initial one. So that's 6 increments of time. So the time between frames is 1 second over 20. Okay. 0.05. So 0.05 seconds. That's the time between adjacent frames. We've got, how many did I say? 1, 2, 3, 4, 5, 6. So the time taken here is 6 lots of 0.05. That is 0.30. So 0.30 seconds. Okay. What else do we know? Well, we know the initial velocity is 0. And we know acceleration downwards is 9.81 meters per second squared. So it's a SUVAT, isn't it? Now, when we have balls dropping from rest, the most obvious SUVAT to go for would clearly be S equals UT plus a half AT squared, which beautifully becomes H equals a half GT squared because it's dropping from rest. So in this case, we have height equals a half times 9.81 times 0.30 squared gives us a height of 0.44 meters. Do not, under any circumstances, just write down 0.4 meters. Okay? Oh, please don't do this as well, which is equal to 0.4 meters. That winds me up. Don't need to do that. Right, use measurements from the photograph to calculate the horizontal velocity. Well, what I've done, the way I did it is, okay, let's go with X and Y again, okay, because we know that's going to be 0.30 seconds. Right, this is where again this is where ruler skills really do become very, very useful. And of course, we are nowhere without a 30 centimeter ruler in any physics lesson, let alone an A level. Right, so if you're doing freeze frame, especially if it's a bouncing ball, right, you've got to. I'd go with the bottom of the ball. You could go with the middle, but the middle can vary depending on whether you hit the middle or not. But it's a lot easier to get the bottom or the top. Right, it's hitting the ground. So yeah, let's. This is what I did. I went. Let's go. Okay, let's go. Let's try again, because clearly I didn't use my 30 centimeter ruler, did I? Right. No, I'm not really using a ruler. I'm using a camera tool. So there. And there. Okay. So we need to use a scale. Now, I measured with my 30 centimeter ruler on my paper copy of the exam. I measured that height to be 7.7 centimeters. Okay. Now we've just calculated that that's equivalent to in terms of the scale, that's equivalent to 0.44 meters. Make sense? Right, same scale. How far horizontally does it go between X and Y? So again, let's take the edge of the ball. Okay, so there's one edge there. There's another edge there. Now I measured on my paper copy there, that horizontal distance, I measured that horizontal distance to be 2.6 centimeters. Okay, making sense? Right, now, so using these two scales, we should have, okay, 2.6 over 7.7 multiplied by 0.44. That should give us the true horizontal distance, which is 0.15 meters. Okay, so again, this you are nowhere without skillful use of a 30 centimeter ruler in this question. Really is that simple. Anyway, what have we got? We've got a horizontal distance of 0.15 meters. The time taken, well, it's the same as the drop, so it's 0.30 seconds. And I believe speed equals distance over time. So that comes out at 0.50 meters per second. Okay. Quite a lot of skills going on in that question. Anyway, is this the last bit almost? Right, vertical position. Okay, explain the difference in height. Okay, don't just say energy loss to surroundings. Okay, because there's 2 marks available here, so we need to really sort of describe and explain the physics a bit more than that. So during the bounce, some of the kinetic energy that it hits the ground with is turned into thermal. Okay, which means that it will rebound at a lower speed. If it rebounds with a lower speed, it's rebounding with a lower amount of kinetic energy. And if it's got a lower amount of kinetic energy to start with on the way up, it's going to gain a lower amount of gravitational potential energy and reach a lower height. Okay, so there you go. 2 marks there. So yeah, just saying energy loss to the surroundings would not be sufficient. And finally, here we go, almost. Draw the first 4 positions. Right, if there's no horizontal velocity, it's just going to drop vertically downwards. The reason is because vertical and horizontal motion in any projectile are totally independent of each other. So that will drop with exactly the same vertical acceleration. Now, let's draw some lines on, okay? Yeah. So if we draw these lines here, this might help us. In fact, it might help us if I do it properly or correctly. Okay, so yeah, again, ruler skills were really useful here. I'm drawing it onto a screen, so it's not brilliant. But if I draw these, they're meant to be horizontal lines cut to the bottom of each ball. Now, if I draw a vertical line going down there, that will mean that it'll be very easy for me to draw. Right, so the first frame, same position. Second frame, same height. Third frame, same height. Fourth frame, same height. So the same height for each frame, but no horizontal motion. Because horizontal and vertical motion in projectiles is independent of each other. And both balls will drop with the same value of acceleration, 9.8 meters per second squared. The same value of vertical acceleration, 9.81 meters per second squared. Okay, right, is that it? Yes. Total for paper, 90 marks. Right. There we have it. Paper 3, done.